Hi everyone, today I will bring a talk about our work, confidence-based 3D semi-supervised learning. Firstly, I will introduce some existing works. Many methods has been proposed for semi-supervised learning, such as FlexMatch, mixed-match, FlexMatch. However, directly implement 2D semi-supervised learning method on 3D cannot achieve satisfied results. Besides, compared to the 2D dataset, 3D point cloud data is hard to be overfitting. Finally, unlike 2D dataset, 3D dataset is inherently imbalanced. The fixed match is a common used semi-supervised learning method. It has two models. The teacher model utilizes weakly augmented image as input to teach the student model, which utilizes the strongly augmented image as input. However, there's a big drawbacks of fixed match. It utilizes the fixed threshold, which harms the performance. To solve this problem, fixed match proposes a curriculum pseudo-labeling to dynamically choose the threshold. However, we still find some drawbacks for fixed match. Firstly, it doesn't demonstrate the correlation between numbers of high confidence instances and the learning status. Secondly, it cannot be implemented in imbalanced dataset. Hence, the motivation of this work is to dig into the reason for better performance for 2D semi-supervised learning. Secondly, we find that there's a high correlation between the class level confidence and the test accuracy in both 3D classification and detection tasks, like two figures in the below. Based on this finding, we propose a 3D specific semi-supervised learning method. This is a framework for our method. Our framework utilizes average confidence on unlabeled data to resample both labeled and unlabeled data. Besides, average confidence is implemented as dynamic threshold to choose the pseudo-label. The first part is the dynamic threshold. The first step, we obtain unlabeled data class level confidence. Then we use the class level confidence to obtain dynamic threshold for each class. Finally, we use the dynamic threshold to filter unlabeled instance as pseudo labels. The second part is the data resampling. Even with the proposed dynamic threshold, learning status between classes still remain imbalanced due to the imbalanced dataset and the invariance of learning difficulty. To solve this problem, a resample method is proposed to increase sampling probability of low learning status classes. To evaluate the performance of our work, we conduct experiments in both 3D classification and detection tasks. This is the result for 3D classification tasks in ModelNet 40 and scan object dataset. And this is the 3D detection tasks on some RGBD and ScanNet dataset. We can find that our proposed method significantly outperforms the sorter methods in both 3D detection and classification tasks. So all in all, we have interesting finding that the class level confidence can represent the learning status of each class in both 3D detection and classification tasks. Based on this finding, we propose a novel dynamic threshold and resampling strategy, and our proposed method outperforms the sorter methods on both 3D detection and classification tasks.